In this video, I will go over the homework 2.1, which follows the lecture 2.1 Logarithms, Logarithmic Functions, and their limits, and hopefully you watched all these lectures before starting this homework. So let's take a look at what's on the homework. And the first question is to simplify the following logarithmic expression. And this homework will have a variety of problems covering simple and not so simple tasks involving logarithms, and simplifying it is one of them. They don't actually tell you simplify, they tell you to write it as a sum or difference of simple logarithms. And let's see what we can do here. We're going to use the property that logarithm of a ratio, it's the difference of the logs. So by this property, this becomes log 12 of 1 minus log 12 of 7 to the power 4. And we can apply this again. So if we have another number here like CD, then it will be log B of D with a negative sign. If we had something else over here like E, then everything from the numerator would come out with a positive sign, and everything in the denominator will come out with a negative sign. So I'm just going to apply that property here. And the next property we're going to use is that, well, first of all, log of 1 base anything is 0, because b to the power 0 is always 1. And the other property we're going to use here is that log of a to the power k, k can come outside of the logarithm as a coefficient. So these are the next properties that we're going to use. So the log of 1 base 12 is 0. So we have negative 4 log of 7 base 12. And we have negative 8 log of x base 12. So, and now it looks pretty simple. So let's type the answer. And hopefully I typed it correctly, and we're good. Use the graphing window below to graph this function. And before we graph anything, let's play with Desmos here. So if we have a function that is a log base b of x, then depending on b has to be greater than, well, let's make it greater than 1, and we don't want it to be 1. So let's say this is our b. As you can see, nothing happens when b is equal to 1, but when b is equal to 2, this is what the graph of a logarithmic function looks like. So one property that they all have in common is that the x-intercept is always 1. So evaluating this function at 1 gives us 0. So if I create this table, then at 1 we should get 0. Now, the other value at which it is easy to evaluate is actually b. So whatever your b is, log of b base b is equal to 1. So as you can see, looking at the graph, depending on b, the higher the b, the output of the function at b is still equal 1. So that's what kind of determines that, how steep is the bend. So knowing this, let's take a look at this problem, and with some coefficient k in the front, everything just gets multiplied by k. So if k is equal to 5/2, then the output at 1 is 0, and the output at b, in this case b is 5, is equal to 2.5. So this should give us a decent graph. There you go. I'll have another graph. So what happens when your base is the reciprocal of some integer. As soon as I can figure out how to type that. It doesn't like... Huh. Interesting. So let me just type 1/2. Huh. Doesn't like 1/2. So let me put 0.5. But, well, let's keep it as b, but b will be the reciprocal of some other number. Let's say some integer n. And as n changes, so what do you see? The graph has actually flipped, right? But the properties haven't changed. It's still easy to evaluate at the when x equals 1 and when x is equal to the base. So what do we have here? We have the coefficient is equal to 7/2, and the n is equal to 2, so we have reciprocal of 2 in the base, and evaluating it at 1 gives us still 0, and evaluating it at b, which is 1/2, gives us 3.5. So at 1/2, it's going to be 3.5. Now, this one only requires you to understand the logarithmic notation. So when b to the power n is equal to a, this means that on one hand, log of a base b is equal to n, or on the other hand, it means that b is equal to nth root of a. So in this case, what we have is, and it goes all the way around. So in our case, if we have log of, what just happened? For some reason, the homework just closed. Luckily, we went back to the same problem, but so what does this question implies? Well, it implies that we're trying to rewrite this expression to understand it, and one way to rewrite it will be to say that 5 is equal to 4th root of 625, which is true, but we actually want the following statement out of this. 5 to the power 4 is equal to 625. And that's what it means to write it in exponential form. The other one will be radical form. Another one with graphing utility. So here we have the coefficient 7/2. Log is base 3. And at 1, it's going to be 0. And at 3, it's going to be 3.5. Another one of the same type, so we need to get used to graphing this logarithmic functions, but it's, again, once you understand the properties, it's pretty straightforward. At 1, it's 0. At 4, it's going to be 2.5. In this problem, we are asked to rewrite exponential expression, and we are asked to do to rewrite it in a certain way. So it says write it as a single logarithm. So to do that, the first property I'm going to use is this one. Log of something to the power k base b can be written like this, but I'm going to use it going from the right to the left. So I'm actually going to be bringing k inside of the log as a power. And I'm going to do this property exactly 3 times. So and next, I'm going to use the property of logs that allows me to combine logarithms. Oops. Like this. So the sum of the logs with the same base can be written as a log of the product. And when you have sum of 3, it just becomes a product of 3. So this is the final answer. And Newton gives you all the names, but when you use the property, you don't really care what the name of it is. Next question. What is log of 58 base 14? And the problem here is that if you're using calculator, your calculator doesn't have a log base 14 button. But your calculator probably has log base 10, which is called a common log, or log base E, which is called the natural log button. So using the change of base formula, you can write this as log of 58, which is log base 10, over log of 14. Or you can use ln button if you rewrite it like this. So now I'm going to grab a calculator. Actually, I'm not going to grab a calculator. I'm just going to put it in Desmos. So log of 58 divided by log of 14. And the answer is 1.538596. Or I'm going to put ln of 58 divided by ln of 14. And guess what? The answer is exactly the same. So there's no need for this or. Now we're ready to answer the question. Rounded to 3 decimals, the answer is 1.539. So again, going from exponential notation to logarithmic notation and radical notation is something that we should be able to do. So in this case, they give us exponential notation. So in radical notation, it kind of makes no sense because we don't take radicals like first roots, but technically there's nothing wrong with writing it like this. But what we are after in this problem is actually this. So the final answer is log of 14 base 14 is equal to 1. And as a matter of the fact, this is true for any number other than 0, probably. And probably we don't want to deal with negative numbers either. So any positive real number. Except maybe 1 as well. Because log of 1 base 1, well, 1 to the power of 1 is 1 to the power is, yeah, it should work for 1. So any positive real number. And we finished this homework. If you have any questions, feel free to reach out.